We are going to process Q-brain for the Ictal and Interictal study, where we have a baseline and CT and the Ictal study.
Okay.
So select the left start tab.
Now, which protocol do we need to select for
This Q-brain,
this?
Q-brain and left start. In here you have to select the proper tracer from this list. Let's say ECD and this one also. Save for future use. Click OK. Okay, so this screen is for the motion movement correction of the head. Here we have X and Y direction. You have to just click auto. It's fully automatic motion correction.
Okay.
So this set is corrected one and left side is uncorrected one. You can see the lino and sino. If there will be a drastic movement, you will see a proper correction. And left side there is an option to select the corrected or original one. Let's select corrected. Similarly for the second data set, that is the Ictal study, click auto and select corrected. This screen is to select the how many types of images data sets you want. Like you want a resolution recovery, scatter correction, attenuation correction. This one is the measured and this is the Chang method. Chang method doesn't use CT data, yes, and measured will use the CT data. Then proceed.
So by default, measured is selected.
Yes. This screen is for registering the two data sets because you are going to compare the ictal with interictal. Both should match so that you can do a pixel to pixel comparison and you can do the subtraction between ictal and interictal. So it will use the CT data for registering the interictal study with the ictal study. So this is fully automatic, no need to do anything. You can see it's automatically registered, right? See, this is the NM. Now this image and this image should perfectly register. So this red line is showing this is the image, this image, and this image is shown as this ROI, and then full registration. If you have a MRI image of the same patient, you can load the MRI data in this and you can fuse with the actual MRI data. This one is the quantitative data. Images you can change the color, G color. These are the quantitative information about each particle. This shows the patient uptake ratio. This is the normal database uptake ratio, and this is the difference between the normal and the patient. And these are the Z scores. The positive Z score shows that higher uptakes. VOIs, there are different layouts. You can click and choose different layouts. This is the 3D surface projection. If you want to display the VOI on the slices itself, you can do that. If you place the mouse on that, you can see the values directly on the slices. Here you can select the different layouts. For example, if you want uptake ratio with CT, this one is the subtracted image late minus early, that is ictal minus interictal. So this is the subtracted images. So you can see after subtraction you can see the higher uptake here. That means there is a difference in the uptake in this area. Okay, this feature was not available previous versions of the software. This is something new. This one is the Ictal. Okay, so this image is very important to for the interpretation. Like this image here, if you see the uh, color scale, this one, the red is like a good uptake. So here the red is good, but if you see this color scale, it is the less number is on the top and big number is below. That means it is a reverse scale. So minus negative number represents hypometabolic areas. So these are the areas. Here the red is bad. So red is negative Z score, it is -6. That means here in this area, which is highlighted in white or red, is actually the hypoperfusion areas. Right, this area. And this black area where you are not seeing any colors, that is normal area. That means there is no difference between the uptake of ictal and interictal. Right? Any question?
No. So this is the page is required to be given to the patient.
Yes. So this is with the quantitative information, and the quantitative information is calculated from the patient data as well as the normal database which this software have, and the difference gives the abnormalities in terms of Z score. For normalization, you have different options here as a reference region like pons, cerebellum, and global. Right. So you can see different normalization areas shows different extent of the disease. Okay, mostly if it is Alzheimer and dementia kind of diseases and you are using FDG, then you have to select PONS as a reference. For ECD and HMPO, you are seeing actually the cortical areas, so you can select the global instead of PONS. So here you can see the negative Z scores and corresponding perfusion areas. So now the perfusion image as well as that is clinically correlating.
Okay.
Yeah.
Thank you so much.
Thank you.